Hey there, future scientists. Today, we're diving into the world of electricity with a super important concept called Ohm's Law. Trust me, by the end of this video, you'll be an Ohm's Law pro. First things first, what is Ohm's Law? Well, it's a fundamental principle in electricity that describes the relationship between voltage, current, and resistance. This amazing law is named after the German physicist Georg Simon Ohm. Ohm's law states that the current flowing through a conductor, like a wire, is directly proportional to the voltage applied across it and inversely proportional to the resistance of the conductor. Sounds a bit complex, right? Let's break it down with some fun examples. Mathematically, Ohm's law is expressed as I equals sign VR, where I is the current in amperes, A, V is the voltage in volts, V, R is the resistance in ohms, omega. Alright, let's start with the relationship between voltage and current. Imagine you're watering your garden with a hose. The water pressure or voltage pushes water through the hose. If you increase the water pressure, more water flows through the hose, which means increased current. Simple, right? For example, if you double the voltage across a conductor, the current will also double, assuming the resistance stays the same. Easy peasy. Now, let's talk about resistance and current. Think of the hose again, but this time it has a narrow section that restricts water flow. This narrow section represents resistance. If you increase the resistance, less water flows through the hose, which means decreased current. For instance, if you double the resistance of a conductor, the current will be halved, assuming the voltage remains the same. Alright, let's bring it to the real world with a practical example. Suppose you have a 9-volt battery connected to a small light bulb with a resistance of 3 ohms. Using Ohm's law, you can calculate the current flowing through the bulb. I equals sign VR equals sign 9V30 equals sign 3A. This means 3 amperes of current will flow through the light bulb. Pretty neat, huh? Here are some key points to remember. Ohm's law only applies to conductors, not insulators. The law assumes a linear relationship between voltage, current, and resistance. Ohm's law is widely used in electrical engineering, electronics, and circuit analysis. I hope this explanation and examples helped you understand Ohm's law better. Keep experimenting, keep learning, and keep having fun with science. Catch you in the next video.